Okay, we're going to do the shell method for this problem here on my left. So we see that we are rotating around the y-axis. And just as a reminder, if we're rotating around the y-axis, we need the radius to be an x value. But if you look at the formulas that are given, y is equal to square root of x plus 1, and y is equal to 1 and x equals to 4. We would have to convert this into a x value. And I don't want to do that, let's say. So, so it would be faster if I did my shell method. So here we go. Our shell method is 2 pi rh, right? That's the integral dx. We're going to give ourselves some space, 2 pi integral, and then we're going to figure out what my radius is. So the radius is the distance from here to here from my cylinder. We're crawling our cylinders out. So if I draw a cylinder, one cylinder here, you can see that the radius is just the same thing as the x value here. The height is the upper equation minus the lower equation. In this case, it's the square root of x plus 1 is my upper equation, and the y is equal to 1 is my lower equation. This simplifies out to 2 pi x square root of x. And one more step is to make sure I got my a to b value. A is, looking at the graph on my left, we're going to start from 0. We're going to crawl our cylinders out to 4. 0 to 4. dx. Okay. Similar problem over here. We are crawling our graph out. Here's a graph, here's a graph, here's a graph. Okay. So if we're rotating it this way, we're going to need this would be my radius, but the problem is you can see that the radius actually changes from this equation and this equation, which makes this a harder problem. Well, if I just draw cylinders, let me just draw you one cylinder here. Okay, this cylinder would handle the changes in the radius. So I'm going to use cylinders instead. Cylinder is 2 pi, this problem goes from 0 to 1. If you guys look on my left, it's 0 to 1, 0 to 1. The radius, since the axis of rotation is on 0, the radius just comes out from here to my cylinder, which is just x. The height of my cylinder is starting up at 5 here, subtracting all the way down to the equation. So it's 5 minus the square root of x. Upper minus lower, dx. That is the equation to find the volume through shell method. Okay, a solid lies between the perpendicular the solid lies between planes perpendicular to the x-axis between 0 and 15. 0 and 15. The cross sections perpendicular to the axis on the interval from 0 to 15 are squares with diagonals that run along the parabola. Ooh, these okay. The diagonals of the squares run along the parabola -2 square root. So we're looking something like this. -2 square root to the parabola on top, 2 square root. Okay. So this is what our graph looks like from 0 to 15. And we're looking at the cross sections of the perpendicular to the axis of rotation are squares with the diagonals. Okay. So the diagonals are on let's see if I can draw this. I'm not sure I can draw this. Okay, so the diagonals are on the square, okay? Alright, so here we go. We're adding up the bases. We're going to multiply them by a little bit of thickness. So integral from 0 to 15. And what is our area? And what's a little bit of dx? The area of our shape here is going to be squares. Now the thing is, for squares, you have to think about what is the equation for squares. Well, we know squares are s squared, right? But if you look here, s, that's not the side we're thinking about. So how would we find the area of a square with a diagonal on the base? Now I'm going to draw it this way a little bit, so you can see the cross section, and this is your S.
Use two triangles?
Two triangles. I'm trying to think of a different way. Maybe if I call this S, and there's there are basic geometry way. If I just go ahead and switch this and call this 1/2 S, and since these are 45 degrees, since it's a square, this is going to be 1/2 S square root of 2. You guys remember that? Right, so we took half of S to get to our triangle, one leg of our triangle, and then we said that's just the square root of 2 version of that. If you want, you can multiply this by S squared now. So our S squared, our area, is actually 1/2 S square root of 2 squared. Okay, when I square this, is 1/4 S times 2, which is 1/2 S. S squared, I'm sorry. No, I'm trying to think of another geometric way of doing this. If I went ahead and made my S into a square on one side, okay, we did this before and we said, isn't this 1/4? Just looking at the top, isn't this 1/4 of S squared? Just the top. And so if this shaded section is 1/4 S squared, the bottom section is exactly the same. So 1/4 plus 1/4 is 1/2 S squared. So we would have gotten the same answer. This was number 1. Emily, this is number 1. So the area that we're adding up a bunch of squares. So integral from 0 to 15 of 1/2 S squared, which is, now what's S now? S was the distance from the top equation to the bottom equation. So for us, we said the equation was 2 square root of x, and the bottom was 2 square root of x. So it's 1/2 2 square root of x minus negative 2 square root of x squared, and then dx. Okay. You can simplify that. Integral from 0 to 15, that's 15. 1/2 in the front. And if I add those together, that will be 2 plus 2 is 4 square root of x squared dx. 1/2 integral 0 to 15 of 16x dx, which is just integral of 8x dx, 0 to 15. Okay. Okay, let's look at the next question. Question number 2. So question number 2 is similar, but a little easier because I'm not asking you to do the diagonals. Number 2, we have a graph similar to before. We have this time a circle. This is actually a circle. If you see x squared plus y squared equals to r squared, what they gave you was the square root of x squared plus y squared equals to r, right? Okay, so these are circles with the radius of 5. So the equation they gave us was the square root of 25 minus x squared. The bottom equation was negative square root of 25 minus x squared. So these are circles. So find the solid between the planes perpendicular to the x-axis from -5 to 5. -5 to 5. Thank you. The cross sections are going to be squares whose bases run on this from the semicircle, the top and the bottom, which is actually a full circle now. Find the volume of the solid. Okay, so to say one shape here is going to be a square, right? Where the top to the bottom that's my S. The S is equal to the square root of 25 minus square root of x minus negative square root of 25 minus x squared. Sorry, that was x squared. we can rewrite this as s equals 2 square root of 25 minus x squared. Emily, are you okay so far? Okay, so that's our s value. So that's the length from here to here. What's the area of a square? Just s squared. So we're just going to add up from -5 to 5. The area times a little bit of dx gives us a volume. We're adding up square volumes. Integral -5 to 5 of 2 square root of 25 minus x squared squared dx. We can see that the squares cancel out. So 4, 25 minus x squared. You can type this in your calculator if you want. If you might save some time if you simplify a little bit more. So it's 100 minus 4x squared. Okay. Okay, question number, next one I see on the list is number 4. All right, so I will tell you the idea here, but I don't want to give you all the answers. So for number 4, the problem looks something like, in general, let's just call this x equals 2. Okay, they gave us our x equals to some value, and they said 8 tangent of pi over 3 y. Looks terrible. Okay, it looks terrible. Find the volume of a solid generated by revolving the shaded region around the y-axis. Okay, so you want us to revolve it around this way? Y-axis. They told us the x value. As you can see, that's my radius, isn't it? And if I rotate it around, we end up with what type of shape? We end up with a circle. And we're adding layers of circles together. This is a disc or washer. You want to remember that? Remember that? Is that a disc or washer? This is a disc, right? So we just, the equation is pi r squared. Integral pi r squared dx. And our problem, we're going to go from the bottom to the top, 0 to 1. So going from the bottom all the way to the top. So we're making circles along the graph. These areas of one circle will be just pi r squared. The radius goes from 0 to the graph itself, which is our x value. That's our r value. So in this case, it's going to be pi integral from 0 to 1. And our r value is 8 tan blah, blah, blah. And with a little bit of dx. Now, I want to change this problem slightly differently. What if they gave me a different axis of rotation? What if they shifted the rotation over here? Let's say to -2. So if they do that, can you see that the radius actually increased? So if the radius increased, it's just right minus left. It would have been x. In this case, it would be the radius is equal to 8 tan blah, 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 minus a -2. Look what happens to the negative and negative. They become a positive. So it does add to your radius. And that's our r value. And that's the only difference that changes. If this is still one huge disk. If they cut it and make this into a washer problem, let's say the washer problem is just this section here. So we would have to do outer minus inner, and that would be r squared minus r. Well, the outer radius would be the distance from x to the axis of rotation, and the inner radius would be from 0 to the axis of rotation. Okay. Emily, are you okay with the setup for this problem here? For number 4? Okay. Someone asked me about how to do 5. Find the volume of a solid generated by revolving the region. Okay, so this one is just a regular volume problem. So they gave us some y is equal to, number 5, y is equal to 2x squared, and y is equal to 0, x equals to 2. So graphing this out is just a simple parabola, where we're stopped at y is equal to 0, and x is equal to 2. So this is our shape going on. We're revolving this way, along the x-axis. So this one is just pretty traditional. I just want to make sure you guys are cool with finding the radius. If I'm spinning around the x-axis, the radius is take a look here, is that an x value or a y value? This is a y value, right? And they give us our y equation. So and does this look like a solid disk or a holy washer? Doesn't look like there's a hole in it. So this is just going to be pi r squared. In this case, from 0 to 2.
That's all the work I showed. Do I have to also, like, can I just write, I put it in the calculator, or do I have
Yeah,
to show
that's it.
more?
No, calculator. These are 6-minute
Okay.
problems. Okay. It probably took you less than 6 minutes to set it up. Right?
Yeah.
Okay. And the goal of this test is that you can already identify which method you're going to use. Is it going to be disk and washer or cylinder? Because do you have to change your variable? And then if it is a hole, what would be your outer radius, what's your inner radius? If it's a perpendicular cross section, which shape do they want you to build your bases off of? And do you remember what the formula is? There's a cheat sheet you can look up online. You probably have a note with which equation for what shape already. Okay. Anyone else I can help you guys out with? Any other questions?
There was also number 8 on there.
Sure. Thank you. Let me go jump to 8.
There was like, to find like the x values for it, I had to graph it on Desmos.
You can graph it on Desmos, or you can graph it on your graphing calculator. Desmos would probably be faster in this case, but on the AP exam, you have to use your. You have to use your graphing calculator.
But you can't put CSC on the calculator.
Right. So if you can't put cosecant on your calculator, if you remember cosecant.
1 over sine.
Yeah, so you would write 1 over sine.
Okay.
Or you would remember that cosecant graphs are the reciprocal of sine graphs.
Mm-hmm.
Right. And that's a very typical, that's a straight cosecant graph. It's not changed in any way. So find the solid generated by revolving the region about the graph and y is equal to 2. Okay, so square root of 2. So I'm thinking square root of 2 is somewhere, right? Square root of 2 is going to be something like up here. And from 0 to pi. So here's pi. And then we have to figure out, okay. So the reason why I know this is because a sine graph goes this way. And the y value is 1, right? So square root of 2 is bigger than 1. So that's why I figured it's going to trap it on top. And we know that the sine graph goes from 0 to 2 pi. So one loop would be at pi. It would be helpful if you remembered how to graph these.
When I graph it on the calculator, would I also write the boundaries like 0 greater than or equal to x greater than or equal to pi?
Let's see, they want us to spin around the x-axis, right? Mm-hmm. So the x-axis, we know it's just going to be from 0 to pi. So 0 to pi.
Yeah.
And then we have pi r squared. So we actually didn't have to look for that. The hard part is that you have to figure out, is this a washer or a disk? Because now we're spinning this section around in this manner. Would that be a washer or a disk?
A washer?
Yeah, washer because we have because we have a big hole in the middle.
Yeah.
So all you're doing is just saying outer radius. So this is pi r squared minus r squared dx. So like part of the test is knowing which equation to use because that's how fast you have to figure it out on the calculator.
Wait, why is it a washer again? Like how would you visualize that?
So I'm seeing this is my shape and I'm spinning it across the x-axis where there's a gap. So if I want to draw it, it looks like the mirror image is over here.
Oh.
See how there's a big hole in the middle now.
Oh, that makes sense. Okay.
So this is pretty much a cronut, almost you could say. Maybe just a regular donut. The sides would have been straight. It would have curved in. And then we would have to fill in. like that. Where the ends end up, right? Something like that. Okay, so the outer radius. So I like drawing lines to make it easier. And the outer radius goes from here to the axis of rotation. That's square root of 2 minus 0, which is just square root of 2. The inner radius is just my y value. Thank you for us being 1 cosecant x. Cosecant x, yeah, just cosecant x minus 0 squared. And that is my equation. So 2 minus cosecant squared x. So since you guys don't have a cosecant on your calculator, you're going to write 1 over sine x squared. Okay. Anyone have any other questions I can help you guys out with while we're still in class? This class is pretty much done in like 4 minutes, 3 minutes. Work on this today. I'll answer more questions tomorrow, the ones that you get stuck on, because I'll see you guys again tomorrow. And then the goal is to be able to do each of these questions in 6 minutes or less, right? Because that's, you have like half that amount of time on the AP exam. Because the goal is to be able to see the question, say, okay, this is this type of question. Now I can just use my formula for this type of question.
How many questions are going to be on the test on Thursday?
No more than 8.
Alright.
8 times 6 would be 48.
Alright.
And if I do more than 8, we're just kind of repeating questions already. Okay. So I think a big deal is that you guys want to practice on your calculators so you guys can crank out these numbers. And if they want you to write the answer in terms of pi, let's say your answer came up with like 3.14, right? Duh. Or 6.28. And you're like, oh, what's the pi? Divide this by pi, the actual pi number, and that'll give you 2, and this will give you 1, for instance. And that'll give you the number you can write in pi form. That's 1 pi, and that's 2 pi. Okay. If you guys don't have anything else, I guess we're out of time today, and you guys have another period to go to. So you guys can, I'll see you guys later.
Thank you, Mr. Ko. Have a good one.